So now, this is important, so I need you guys to stay where you are. We have time for some discussion and some reflection. I believe we have some facilitators that are going to help do this. Introduce yourselves first, that everybody knows
Sure.
what's going on.
Okay. Hi, everyone. My name is Callum Arnold. I'm a third-year PhD student in Matt Ferrari's lab, actually. My work primarily revolves around how the decisions we make in categorizing and discretizing continuous values like a IgG from a serology test, how that affects our understanding of an outbreak and how we respond to it. Just to give you a quick outline of what's going to happen, as Matt said, this is a discussion group. So whilst we're here at the front, what we really want is to try and get questions from the audience to talk about the broad pictures for the next 20 years of EID in our field, but also this can be an opportunity to pose questions to the authors, to the speakers that you heard that you didn't have a chance to ask earlier. Okay, so
turn the light on.
Hello, everyone. I am Faith Romanov. I am a now fourth year in the Stevenson Lab at the University of Pittsburgh, and my work mostly deals with parasite-mediated sexual selection and how mating behavior affects transmission of parasites.
Hi, everyone. I'm Ben Golis. I am a veterinarian and quantitative disease ecology postdoc between U.S. Geological Survey and the Webb Lab at Colorado State University. And my work largely involves taking individual health and physiological statistics and traits and trying to scale them up to make inference at population, community, and global levels. So to start things off today, all of our talks, of course, have been, this is the transmission section. And within disease ecology, I feel like we have a similar problem that ecology as a field faces, in that it seems like everything depends. It depends on whatever question you're trying to answer. It depends on a lot of the systemic characteristics that are involved. However, we've also found that increasing the complexity of the questions that we're asking can muddle the field too much to make real inference. So I wanted to start by opening the field to ask you all what we think might be universal data sets or concepts that we need to try to answer to be able to give the general world populace more clarified answers to their questions of what's going to happen next when the next new outbreak happens.
Yeah, I guess kind of related to that idea, a lot of the talks we heard today were focused on mobility and its effects on transmission. And even the non-human disease talks were still focused on the mobility of birds, which seems like one of these things that can be important, but also very context dependent and situation specific. Whereas environmental drivers like climate, temperature, rainfall, habitat, these things might have effects at larger scales and might be more easily predictable and easy to measure from afar as well. So I'm curious about the interactions between those environmental and climatic drivers and mobility.
does anyone have any further thoughts on that? Yes, please.
Thanks. That's really well said, and it's been a brilliant session, I think. I've just got one recommendation. It's something we're interested in. It's often really powerful, I think, if you perturb a system and then try and predict what happened. So thinking about endemic infections, one, as many people will know, one side effect of the COVID-19 NPIs has been a vast reduction, but a very variable reduction, not so much rhinoviruses, in the great respiratory viruses. These are endemic infections, so that they're a little bit better understood, though not fully understood in terms of the dynamics. So that's a recommendation to think about that huge perturbation and natural experiment on the system. We've not even started to think yet about the evolutionary implications, but that's an example where you could just make use of, what happened to your favorite endemic respiratory pathogen in the last couple of years, and can you model it?
So do you mind if I just follow that up with a question, Brian? So on that topic and on that point, do you foresee that we should be building models with multiple diseases more commonly in order to actually study the effects of these perturbations?
So that's a great point. The interactions. Okay, I got the mic back now, and then I'm going to give it up forever. That's a great point, and I missed that out. The interactions, they're second order, obviously, but the interactions, cross community, and so on. The perturbation is potentially very powerful, though. You know, as Jess Metcalf and Michael Miller and I bang on about, and I won't say this again. If we knew the serological picture through time, we'd be in a much more powerful place.
Yeah.
Hi, yeah. So one of the things that I think you presented kind of as a problem that I don't think it really is the problem of like how context dependent things are or the complexity of the models. I don't really see it as a problem, and I said this as an ecologist, but I think I see it as an opportunity to think about which questions are answered best at which scale. And on that topic, I would, instead of maybe we're just trying to fool ourselves by looking at generalities, but really thinking about how do we better add the context to the questions that we're asking. And by the context, I mean most of the presentations about mobility. And I think this discussion with COVID-19 and the mobility patterns were centered in the global north, where we have a lot of data in a very specific context, where we talk about commuting and in a very specific and global north context. But then when you switch that question to other cultures or other even in I'm thinking about the global south, and particularly in Latin America, where we have other challenges. So even the same model, it just doesn't, like the same question doesn't work. So I'm just trying to think about it as reframing the questions more than just looking at it as a problem.
So maybe as a follow-up to that, and actually related to something Alex and many of the talkers today were talking about, do you foresee that it's more important that we push forward more on developing better models that can adapt to the lack of data availability, or that we should be putting more effort into sourcing better and more useful data for a specific context?
So I was thinking about both, but thinking really more creative ways to collect data in some contexts that, I don't know, I'm just trying to think of an example and I cannot think of one right now. But yeah, think about creative ways of collecting new data in different contexts that just might not work. And for example, just thinking about, I just came out with an example, cell phone data. And in some contexts, it's just not realistic to collect it that way.
So Ellie, I think Alex might have had his hand up for a mic, but maybe
We have
not
one in
you.
the back
Put
as
you on the
well.
spot. No, okay. Yep.
I wanted to raise, I think there's sort of two different discussions that are starting in response to the original question. One is really about specific prediction, right, in diseases and what we need to be able to tell the public from that perspective. I think another piece to think about is more the building up of our conceptual framework about how the ecology and evolution of infectious disease works. And I wanted to provide perhaps a counterpoint within that context to Brian's suggestion that we look at endemic diseases. One of the things I'm really interested in is how highly virulent diseases can persist, even though there are continuing outbreak dynamics. And I think these two perspectives are really interesting endpoints on a continuum, right, that potentially describes a lot of different disease systems that we're interested in. And so I think one of the things that we need to think about when we are thinking about what our conceptual models might look like is something that Brian suggested in terms of modeling multiple diseases, and then trying to abstract from that what the underlying conceptual model is that perhaps provides some cohesiveness for those. So it may need to be more of a conceptual model from that perspective than an actual detailed model. But I think looking at these two endpoints of endemic diseases and persisting highly virulent diseases will really help provide some insights into what that conceptual framework needs to look like, because those are two extremes that we need to be able to cover.
So I find it very gratifying to see how the field has moved in the last 20 years. And that was an exceptionally good group of talks, as Brian said. They were, and Megan, forgive me, they were primarily modeling talks, and they were primarily about human infections. But if we're really going to understand the mechanisms and what's actually going on, we need to challenge these, not just with conceptual models or with perturbations, but also with the killer experiment, the experiment that is really going to give us the insights into the dynamics and what is taking place. Now, that, of course, is extremely difficult to do in the human scenario situation. And I guess that's why Brian talked about perturbations. But there's still, you know, some real challenges that we can get to grips with. And Megan, excuse me again, by looking at wildlife diseases and being able to perturbate the systems, being able to apply experimental procedures in the right way. Sometimes that's really difficult to do. And I think people should have the guts to stand up and say, to really test this model, this is the killer experiment we should do, or this is what we should do to really test it and put those challenges down so the empiricists really can go out and do it. And I hope there'd be funding for that in the future.
So I'll follow up on that actually, because I always hate to admit that I agree with Peter, but I do. I think one of the challenges that I think that especially with mobility data in particular, and our focus on mobility data, but on behavioral, data about behavioral interactions in general, is that we're oftentimes forced to sort of only view those things and only analyze those things in retrospect. Right? Because we have cell phone records about the past. We know what behavior, though we're measuring those as extrinsic variables in these models, rather than intrinsic variables that are actually responding and reacting to pathogens, to spread, to dynamics, right? And I think we've absolutely seen over the last 3.5 years, if I could think of one thing that has been acutely present in all of our lives and all the discussion, has been how much behavior responds to transmission and responds to incidence and responds to mortality. These are concepts we've had here for a long time in our field, right? We think about the work that David Hughes has presented for a long time about how transmission and infection in ant societies structures those societies and how those societies respond to that. So we've actually had some really wonderful model systems in insects. I think Sarah Perkins we've talked about this years and years ago, about doing this in experimental systems with rodents, right? Looking at how incidence and transmission in those populations might cause behavioral change and behavioral responses there, right? So I think we do need, I think this to me is a really important place for us to think about how to restructure the way we look at dynamics and models. And actually, rather than looking at behavior as an extrinsic driver, right, we start thinking about how it's explicitly tied, right? How we actually use models to link these two things together so that we can predict what behavior will be in the future and what those feedbacks are. Because I think there are two pressures that are pushing on each other that are heading towards novel equilibria that we don't fully understand yet, because we've been looking at them as separate and removed. So I would love to hear if there are folks in here that have other examples of model systems where they think these kinds of phenomena are happening. Because again, we've seen some of them have percolated through our community over the course of the last 20 years or so.
If I can add something, I think this is a crucial point, but in a sense, is the one that we struggled the most in working with, and even during the pandemic, in a way, for the largest part of those changes of behavior, in many cases, have been mandated, and so in a sense, we don't have that very good training data set that we have for other other aspects of modeling. And I think this is where really the big effort should be done. And this means that we have to keep in place all those measurement platforms about mobility and interactions and behavior that unfortunately are being destroyed as we speak. That's one of the things I wanna be clear. You know, during the pandemic for 3 years, there have been a major effort to have mobility data pipeline that were also inferring on contacts, co-proximity, all was done in privacy preserving ways. And now they would be crucial in understanding really, okay, how they are how our mobility changes because of the seasonal flu, where there is no mandates, etc. But those things are all being, how to say, dismantled at the moment, and that's one of the major issue in my view. So it will hamper again the progress of the field.
I think one of the important factors when we're also talking about experiments is especially in whether we're talking about wildlife versus humans, especially since in wildlife, obviously, we have things like sickness behaviors and behavioral immunology, whereas with people, especially with like, as we've all seen in the past few years, like political extremism where, you know, people will get sick, but then make it a point to go out into the world because COVID isn't real and it's all a hoax. And so there's that additional complication for us humans.
I'd like to add on one additional complication as well. And my PhD, I studied PPRV, which is essentially measles for sheep and goats. And not only is there the animal behaviors added on in the livestock systems, you're dealing with the human behaviors as well, and kind of how they are deciding to do this particular management together. So there are a couple of different layers that I just wanted to tack onto this question that we might want to address in some really interesting systems there, because in those systems, perhaps even more so than the wildlife systems, we might have a better chance of actually doing perturbations in the system and having quite a much finer scale of control. And I haven't heard us talk about it in all those settings, but I know that it's out there. So I invite folks with knowledge of those systems to interact on that.
This is a very interesting discussion. I think in many ways we're expressing our desires for either new kinds of data or the ability to use the existing kinds of data that we have, perhaps to design experiments to generate data that will be pivotal in resolving key issues. And this is a very, I mean, it's a very interesting bunch of people. One of the things that's interesting about this group is we're quite theoretical. There's a lot of modeling that was presented here, and it strikes me that we're missing a big opportunity. We often use our models to take the data that we have and try to draw conclusions, but we very rarely go to the next step of asking, well, what additional data ought we to be gathering, and what key pieces of information are missing in the data that we have? And so that we can, all of us, make a long list of things that would be nice to have, but we rarely can quantify exactly which of those would be the most, would most contribute to resolving those uncertainties. So I wonder if you know, we're talking about mobility here, for example. Yeah, lots of mobility data would be great. All of it comes with its complications. Are there some data that would be particularly useful? And if those data don't exist, can we think of ways to generate them, I wonder?
So the question that I've been asked most by lay people, not scientists or academics, is during the pandemic was, are we done with this thing? Or is there going to be a new variant that emerges that's going to sweep through? So that's the most pressing question in the public's mind. So what are we doing to answer that question? Mobility data is going to be very valuable. Phylogenetic is going to be a lot of that is retrospective. So what do we do to make some clear predictions or understandings about the evolutionary dynamics. That's clearly where weather in this whole thing, part company. We have an evolving system. So are we partnering with people that are doing molecular dynamics appropriately to help inform our models?
So
Well,
I guess
technical answer to that is no.
So I wanted to call back to the weather forecasting discussion, which I really enjoyed. And I think for my mind, it touches on a key question in terms of public policy. I really enjoy EID in thinking about inference and attribution of things that have happened in the past and explaining the ecology and the evolution and the dynamics. But we've seen increased public pressure on prediction. And I think there's some real questions of the limits of predictability that we sort of touched on briefly in terms of, are there chaotic dynamics? And I think metaphors can be very powerful, but we need to be careful to make sure the metaphor is not, disease systems are not weather, right? But these two fields have similar questions. So I guess one thing to me that came up through a lot of different talks is the power of stochasticity in individual events. And so I guess to me, there's this really interesting question. So weather forecasters don't have to worry about Brownian motion, right? Brownian motion exists, but it averages out at the scale of hurricanes. And so when we think about what data do we need, I think there's also some important questions about what are our limits of predictability. So I really enjoy hearing people talk about complex systems because it means that context matters. It means that a bestiary of many different examples matters. But when we're asked to make predictions about what happens a week from now or a year from now, I think we can draw from some of the metaphor of weather versus climate, right? Climatologists ask and answer very different questions than weather forecasters. But in our cases, so Katya looking at founder effects, if you have an N of 1 or 2 or 4, zoonosis, right, in branching processes, this idea of predictability and nonlinearity interacting, I think we should think critically about the limits of predictability. And I think communicating that to senators, right, or to CNN can be very difficult. And so, things like model ensembles. But I think there's some theoretical questions that I don't know, but I think stochasticity is, to me, one of the most interesting parts of our field, and I don't think it's answered in terms of the big picture. Thank you.
I know we have a question right here, but I feel like the last few questions have brought this up for me that Mike Boots brought up that got quite a few chuckles from the audience is people from outside our community maybe playing around with some of these modeling and trying to see for themselves what these answers are and what that has brought up for people on what our role is in regulating and communicating and helping people who also want to know what will happen next. So I think there was a question right up here.
So I think it's my turn.
I want to make sure you're planting as well.
Since I'm sitting next to Cecile, and slightly in response to what Brian said and what Aaron said is, so obviously the mobility data has been really wonderful to understand the spread of COV2. I think one interesting thing to keep in mind is that COV2 was a virgin epidemic, which meant that there was 100% susceptibility throughout the population. So then obviously there's no filtering of the mobility data. And I guess this addresses slightly what Brian said, but also what Aaron said, is that there's a key issue that we need to keep in mind, that for all endemic infections, the mobility is filtered by susceptibility. The susceptibility obviously is related to what kind of age-specific antibody profiles that are floating around in the populations. So I guess my point is that trying to generalize from COV2 approaches to using mobility data to other infectious diseases. That's a very complicated issue unless you have really good serology.
So this is the last question then, and then Sam Shiner wanted to make some announcements about some funding opportunities. So you're all going to want to stay in your seats for that. And then we'll break.
Sorry. Is it on? Okay. I also wanted to return to the weather analogy, because I keep thinking about how with disease forecasting, it's a little bit, I mean, it's quite different from weather forecasting in that if there's a hurricane heading towards Florida, the hurricane's trajectory is not going to be altered by human behavior the way a disease is. And it got me thinking more about climate change, communication and interventions and human, public perception of climate change and the impact of our interventions or proposed interventions. And it strikes me that, climate change is playing out on a longer time scale than an individual hurricane. And pandemic forecasting is a little bit in an intermediate time scale in terms of the feedbacks from human behavior to the dynamics of the thing being forecasted. And it strikes me that we have a lot to learn maybe from, or a lot to potentially collaborate on with climate change modelers, and especially those who communicate climate change modeling and intervention assessment to the public. And potentially those same people have a lot to learn from how pandemics are communicated and how that communication changes human behaviors. And then kind of circling back to somebody else's point, I don't remember who mentioned it about using models to understand what types of data we should be collecting. I think we can also, learn more about what types of data humans respond to make sure that the outputs of our models at the end of the day are being communicated on terms that are meaningful to those human behaviors. So it's obviously a complicated and interconnected, behavior, eco-epidemiological, evolutionary set of feedbacks here. But I think, there could be a lot that we learn from other fields that have had to grapple with this at an even longer time scale, like climate change.
All right, so the mark of a good discussion is that there are hands left up. And so I want to thank our facilitators for generating that. So thank you very much.